Hi students, it's Mr. Nguyen here. Today we're going to be talking about trigonometry ratios and trig inverses in right triangles. So in this lesson we're going to just talk about the three basic trig ratios only, the sine, the cosine, and the tangent found in a right triangle. So what are they? Well, in a right triangle, we use the trig ratios to find the side of a missing side of a triangle, right? So, for example, let's talk about angle A. The Let's talk about the positions of these sides really quick so that we know how to apply them later, right? So OPP is short for opposite. It is the opposite side of the reference angle. In this case, is angle A, right? Angle A is known as the reference angle. That's the angle we use to set up our ratio. And then, of course, we have the side that is next to that angle. It's called the adjacent side, right? The opposite and the adjacent sides are the legs of this right triangle, okay? And then, of course, the hypotenuse is the longest side of the right triangle. And the position of the hypotenuse does not change, right? The opposite and the adjacent may change depending on the angle that we're talking about. So, for example, if we're talking about angle B instead of angle A, the opposite of angle B is now at the bottom, right? That's the opposite side of angle B. And then the adjacent side is right next to it. So it is important to know your reference angle so that you can use the correct um, function or correct ratio. Okay, so let's look at the ratio really quick. First off, sine function is abbreviated as sin. Uh, it's still pronounced sine. It's not sin, right? And then cosine is cos. Is still cosine. You still say cosine. You don't say cos or cos. Okay. And then tangent is abbreviated as tan. And these abbreviations are found on your calculator, right? The three functions. And I do another video on how to use your calculator to do these ratios. So if you want to watch that one as well. So the ratios for these functions are as follows. So let's talk about the angle of reference, delta, as shown in this picture. So right straight across from that angle would be the opposite side of that angle, right? And then the other leg would be the adjacent. And then hypotenuse is, of course, the leg, the side that is across from the right angle. So how do these work? Well, if you are using sine, you're going to have the ratio of the opposite side divided by the hypotenuse. If you are using cosine, then you are setting up the ratio as adjacent over hypotenuse. And then, of course, if you are using tangent, it's going to be opposite over adjacent. Now, these are set up so that you can find the sides of the triangle, right? Given that you only have one side of a triangle. So in a right triangle, you have multiple ways to find the measure of the side. One way is to use the Pythagorean theorem, right? A squared plus b squared equals c squared. But to use Pythagorean theorem, you have to have two measurements, right? Either the hypotenuse and the leg or the two legs. Well, there are cases where you have a special right triangle, the 45-45 and the 30-60, where they have a fixed relationship among the sides. So even if you have one side, you still can use the special right triangle to find all of the missing sides, right? However, there are cases where you don't have a special right triangle and you only have one measurement given to you. So this is the case where we have to use the trig ratios to solve. Okay, so those are the three ways to find the size of a triangle. Okay, and this is applicable when you have one measurement given to you and it is not a special right triangle. Okay, so here we are for short. SOH, sine, is opposite over hypotenuse. CAH is cosine equal adjacent over hypotenuse. And then TOA, which is TOA, tangent, is opposite over adjacent. So we set up these little uh, short shortcut or I guess abbreviation to help us remember is called SOHCAHTOA. All right, so let's take a look at our first example. Okay, so bear with me here. All right, what's given to us? Um, they have to give us an angle because that is the angle of reference that we need, right? And they have to give us one of the sides. Okay, so an angle and a side is given to us. Okay, if two sides are given to us, then we can just use Pythagorean theorem. Okay, so they have to give us a side and an angle. All right, so let's take a look at the angle here. It's angle A that is given to us, which is 13 degrees. You don't want to use angle B because angle B doesn't have any measurement. All right, so you want to use angle A. So if you're using angle A as the reference angle, then the legs AB becomes, so that's the hypotenuse, which is 15. That's given, right? It's always the hypotenuse, right? Now A has become the opposite side because it's right across from the reference angle. And then B is the adjacent side. Now, in this case, we are looking for AC, which means we're looking for the adjacent side. So right off at the back of your head, you say that BC is no use here, right? BC, we're not going to pay attention to the opposite side. So we're going to be using adjacent and hypotenuse. Well, if you look at your list over here, the ratio that has adjacent over hypotenuse would be cosine. So that tells you that you have to use cosine. Okay, so we have adjacent over hypotenuse, so we can set up the proportion, so to say, uh, of cosine. So we're going to do cosine of the angle that's given to us over 1 equals adjacent happen to be side B, or you can put AC if you want. I'm just going to call it B because it's one of the legs, over hypotenuse, which happened to be 15. So after you set up this proportion, all you have to do now is go back to the basics and use cross multiplication, right? And solve for B. So B times 1 equals to uh, 15 times cosine of 13 degrees, right? Or you can put cosine of 13 degrees times 15. However, I tend to put the number ahead of the function because sometimes if you put 15 behind 13 and you don't use the parentheses correctly, it might miscalculate on your calculator, okay? So if you type this into your calculator, 15 times cosine of 13 degree, and make sure you are using degree to work with these trigonometry ratios, okay? Your calculator will give you an approximation answer, right? So 14.6. So we know side AC is about 14.6, which should make sense. It should be less than the hypotenuse, right? And it's according to this picture, it looks pretty long, so it's close enough to the hypotenuse. So 14.6 is reasonable, okay? I do have another video that shows you how to make sure your calculator is in degree mode and how to enter these into your calculator if you want to watch that video, okay? Where I use actual examples and a lot of examples. Okay, so these are just a few examples that highlight the the rules. Okay, all right, let's take a look at another example. All right, this time we have angle 65 degrees, angle A given to us. And the hypotenuse is also given to us, but this time we're looking for side BC. Okay, so again, I'm going to put my legs in, right? Not my legs, the right triangle's legs. Uh, AC is A, and I tend to label A for the shorter leg and then B for the longer leg. Okay, so let's take a look at this. What we have here, side B is actually the opposite, and side A is the adjacent. Okay, so we're looking for side B, which is length BC. Okay, hypotenuse is given to us. So you don't care about adjacent because in this case we're not looking for AC. So we're not looking for adjacent. We're looking for opposite. So we have opposite and hypotenuse. So opposite and hypotenuse, O and H. Well, that's the sine function. This is the reason why we have three different trig functions to use. It's because we're given different information, right? So we have to have options because sometimes we have the hypotenuse, sometimes we don't. Sometimes we have the opposite side, and sometimes we're not looking for the opposite side. So we have three different functions so that we have options. All right. So in this case, sine will work. Okay, cosine won't work because we don't care about adjacent. Tangent won't work because we don't care about adjacent. We don't have anything about adjacent, and we have the hypotenuse. So look at what you have given to you, and then you can decide which function to use. Okay, in this case, we're looking for opposite, and we're given hypotenuse. So here we go. Set up the sine function. So sine of 65 degree over 1 equals to opposite, which is b, over hypotenuse, which is 225. Okay? And then again, go back to the basic and cross multiply. We get b equal 225 times sine of 65 degrees. And if you enter this into your calculator correctly, you should get 203.9. Okay? 203.9, which is also reasonable. Okay? Because the hypotenuse is 225. All right, one more example. Find the length of the hypotenuse. Oh, here we go. In this case, we are looking for the hypotenuse and we are given one of the legs, right? So, and the reference angle is 20 degrees, right? So let's set this up. Reference angle, which makes 4 feet the opposite side, right? And then we're looking for the hypotenuse. We don't care about adjacent because we're not looking for adjacent, right? We're looking for hypotenuse. So tell yourself you have opposite and you're looking for hypotenuse. So that means we have opposite, we're looking for hypotenuse. That means we're going to be using sine function. So sine of 20 degrees over 1 equals opposite over hypotenuse. So opposite is 4 feet over hypotenuse, which is c. All right, and then go back to the basics. We're going to cross multiply. Now be careful here. This is not like before. This time we're looking for hypotenuse. So we're going to do 4 times 1, which is 4, and then c times 20. Okay, now you do have to solve for c because c times 20, sine of 20, it's not going to give you anything. So you have to solve for c. Well, go back to the basic. To solve for c, you divide both sides by sine of 20 degrees, right? So c equal 4 divided by sine of 20 degrees. And then if you enter that into your calculator correctly, you would get 11.6952. Just the direction might give you a rounding error direction. So whatever the direction says, you can round it to whatever. Now, sometimes they say round it to the whole number. In this case, it would be 12. But anyway, so when you're looking for hypotenuse, keep in mind you're always going to end up dividing the function. Okay, when you're looking for the legs, it's just straight up multiplying by the function. Okay. All right, so that's using the ratio to find the side. Okay, using the trig ratio to find the side. Now, what if they're giving us the side and they're asking us to find the angles instead, right? Like this problem. Okay, they're giving us the two sides, the 8 and the 11, and then asking us to find angle x. And then the next problem over here, they're giving us the leg and the hypotenuse, and they're asking us to find the two angles. Okay, so in this case, we're doing the reverse of that. So we're using inverse to find the angles. Okay, so trig ratios, we use that to find the sides. Trig inverse, we use to find the angle. Okay, so keep that in mind. So what is the inverse notation? Well, on your calculator, you would see it's written as sine to the -1 uh, superscript, right? The -1 is not an exponent, so it's not assigned to the negative first power, okay? So to find the angle, all you have to do is set up the same ratio, however, you're using inverse, okay? So opposite over hypotenuse, but inverse instead to give you the angle, okay? So the angle of reference, the angle that you don't know, okay? And then for cosine, you do cosine inverse of adjacent over hypotenuse. And then for tangent, you do tangent inverse of opposite over adjacent. Now, which function do I use? How do I know which inverse function to use? Well, it depends on what's given to you. So they're giving you two sides, right? It depends on what's given to you. If they're giving you adjacent and hypotenuse, then you're going to be using cosine inverse. Okay, so let's take a look at the example. All right, let's take a look at this first example. Our angle of reference is x, right? And right across from x is 8, and it's given to you. So 8 becomes the opposite side. right? And then 11, of course, is the hypotenuse. So you tell yourself, oh, I have opposite and I have hypotenuse, which means I'm going to be using sine function, right? Opposite over hypotenuse. So I'm going to be, to find angle x, I use sine inverse of opposite hypotenuse over hypotenuse. Guys, looking for the angle is actually faster than looking for the sides because it's straight up typing it into your calculator and get an answer, okay? So here's the hypotenuse, here's the opposite side. You set up your sine inverse function for the measure of angle x, and then you substitute the opposite in, which is 8, and then the hypotenuse, which is 11. You type all of this into your calculator, you'll get 46.66 degrees, which you could round to 47 degrees if you want to. Now, make sure, though, your calculator is still in degree mode when you're working with these ratios, okay? Next one. Okay, here we go. We have 9 and 15. So, and we have two angles that we're looking for, and it depends on which one you're trying to find first. Okay, if you find x first, then 9 is your adjacent side. Okay, 15 is a hypotenuse. That's given. That doesn't change. If you're looking for y first, y 9 is opposite of y. Okay, so it depends on what you want to find first. That is gonna give you which function to use. So if I'm looking for x first, right? X, I'm using cosine inverse because 9 is my adjacent. So I just set up my cosine inverse, right? And I find x first, okay? Just because. I type in adjacent over hypotenuse, which is 9 over 15. I type that into my calculator. I get 53.13. So after I get my x angle, I don't have to set up another trig function. I can just subtract it from 90 to get my y angle, okay? Because x and y make 90 degree because the other angle is already 90 degree. So if I already found x, all I have to do is subtract x from 90 to get y, which happened to be 36.87. Okay, so guys, watch my other videos where I do a lot of examples of these types of problems, and I will show you how to use your calculators and enter your values and everything. So thank you for watching, and I will see you again next time. Appreciate it. Take care. Bye bye.